Applications of differential equations to electrical circuits. This is our next topic. Applications of differential equations to electrical circuits. Now, here applying the knowledge of solving differential equations to solve the differential equations arised in the modeling of electrical circuits into differential equations. There we apply the same set of knowledge how to solve the linear differential equations to solve the differential equations arise in electrical circuits. Here, simple electric circuits. First, we have to consider simple electric circuits. Simple electric circuits. Here, we shall consider circuit made up of three passive elements. We shall consider circuits made up of number one, three passive elements. Elements. One is resistance, other one is inductance, third one is capacitance, and second one is an active element. An active element. Active element is either voltage source, it may be a battery or a generator. An active element voltage source, which may be a battery or a generator. So therefore, now here simple electric circuit, we shall consider circuits made up of three passive elements. Resistance, inductance, capacitance. Why these three elements are called passive elements? in an electronic component, passive elements, so it can receive only the energy. It receives energy only, which it can either dissipate, observe, or store the received energy in an electric field or in the magnetic field. So because of that reason, we are calling resistance, inductance, capacitance are passive elements. These elements can receive only the energy. They receive only the energy from the voltage source, and which do not require any electric power to operate. So the passive elements do not require any power to operate. So therefore these three are called passive elements. An active element, so active element has already we written voltage source, that may be battery or a generator. Why this is an active element voltage source? That means in an electronic component, so element active element means which supplies energy to a circuit, the energy supplied by the voltage source can be received by the resistance, inductance and capacitance. That received energy by the resistance, inductance and capacitance, which it can absorb, store or dissipate. So because of these reasons, these three elements are passive elements, and the voltage source, either battery or a generator, is an active element because it supplies an energy to the circuit. So therefore these are the components we are considering in the simple electrical circuits. Now symbols. We are going to discuss symbols to be used in the electrical circuits. Element. What is the element in the circuit and what is the symbol used to represent that element, and what is the unit of representation. Unit of representation. Now element number one, quantity of electricity. Quantity of electricity. Quantity of electricity. The symbol used to represent the quantity of electricity is a Q. Unit of representation for the quantity of electricity is a coulomb. These are all names of the scientists. Coulomb. And second one is current. Current means time, rate, flow of electricity. Rate of change of flow of electricity. Current, time, rate, flow of electricity. The symbol used to represent it is I, and The unit of representation is ampere. Capital A. So the symbol used to this is a capital A. Ampere. Capital A. And third one is resistance. Third one is resistance. The symbol used to represent resistance is this is the symbol used to represent resistance in the electrical circuit is this one, and unit of representation is a ohm. Unit of representation is a ohm. The symbol used to represent ohm is a this one. Now another element is as explained earlier, inductance. Fourth one is inductance. Capital L. So the symbol used to represent inductance is now unit of representation for inductance L is Henry. Henry. So the symbol used to represent Henry is capital H. Now fifth one, capacitance. Fifth one is a capacitance. Capacitance C. The symbol used to represent is unit of representation for capacitance Farad. The symbol used for Farad is capital F. Sixth one, electromotive force. Electromotive force in the short form, this can be written as EMF or voltage. E. The symbol used to represent this one is a battery E equal to constant equal to constant or generator generator power is variable power is a variable power. The unit of representation is a volt for electromotive force. Next one is a loop. What is meant by loop in the electrical circuit? Generator E is equal to variable. So electromotive force is either battery or generator. Battery is a constant power, generator is a variable power. So unit of representation is volt V. Loop is any closed path formed by passing through two or more elements in series. And other one, eighth one is nodes are the terminals of any of these elements. The terminals of any of these elements. Now loop This is loop is a closed path formed by passing through two or more elements in a series. Two or more elements, resistance one element, inductance one element, electromotive force battery is one element. Loop is a closed path formed by passing through two or more elements in a series, and initial point coincides with the ending point, then it is called a closed path. Loop is a closed path. If the path is formed by starting point coincides with the ending points, that path is called closed path. So loop is a closed path. It will be formed by passing through two or more elements in a series, and nodes are the terminals of any of these elements. This is node, this is node, this is node, this is a node. So this is a closed, this is a loop, this is node, this is node, this is node, node, this is node. So these are the node and loop of the circuit. These are the elements, symbols and a unit of representation we discussed here. Next, basic relations. Next, second category, basic relations. Second category, basic relations. Basic relations. Number one, current I equal to rate of change of charge with respect to time t. Rate of change of charge with respect to time, that is rate of flow of electricity. This can also be written as Q is equal to integral of I dt. Since differentiation and integration are the reverse process of each other, inverse of each other, since current is the rate of flow of electricity. Second one, voltage drop across the resistance. R is equal to R into I. This is a Ohm's law. This can also be written as V suffix R is equal to R into I, or V suffix R is equal to R into I. This can also be written as voltage drop across the resistance. Now, voltage drop across the inductance. Inductance L is equal to L into di by dt, or this can also be written as V suffix L is equal to L into di by dt, voltage drop across the inductance. Now, fourth one is voltage drop across the capacitance. Capacitance C is equal to Q by C. Q by C. This is the voltage drop across the capacitance. So, basic relations in the electrical circuits to be used is I already explained dq by dt, rate of change of charge with respect to time t, or rate of flow of electricity. Current is the rate of flow of electricity. Voltage drop across the resistance by Ohm's law. The formula is R into I, or this can also be written as V suffix R equal to R into I. Voltage drop across the inductance is given by L is equal to L into di by dt, or this can also be denoted by V suffix L is equal to L into di by dt. And voltage drop across the capacitance C is equal to Q by C. These are the basic relations we have to use in the formation of electrical circuits. Formation of electrical circuits. Next, third one. Kirchhoff's laws. The formulation of differential equation equations for an electric circuit depends on the following Kirchhoff's laws. Which are of cardinal importance. Importance. Cardinal importance means fundamental importance. Fundamental importance. So the formulation of differential equations for an electrical circuit depends upon the following two Kirchhoff's laws, which are cardinal importance. So for any physical situation, if you want to model the given physical situation into mathematical equations, you require the law behind this physical situation. Here, for an electrical circuits, the suitable principle to model the electrical circuits into differential equations is a Kirchhoff's law. So Kirchhoff is the scientist. He has given the principle to form the differential equations for the electrical circuit. He has given two laws. Based on two laws given by the Kirchhoffs, we have to formulate the differential equations for the physical situation electrical circuit. So the formation of electrical circuit into the differential equations is possible only by Kirchhoff's laws. That is, here we have written the formulation of differential equations for an electrical circuit depends upon the following two Kirchhoff's laws, which are very fundamental, important laws to construct the differential equations for the given electrical circuit. First law says that the algebraic sum of the voltage drops around any closed circuit is equal to the resultant electromotive force in the circuit. The algebraic sum of the voltage drops around any closed circuit is equal to the resultant electromotive force. That is EMF in the circuit. Second one, the algebraic sum of currents flowing into or from any node is zero. So first law says that the algebraic sum of voltage drops around any closed circuit in any element is equal to the resultant electromotive force in the circuit. So sum of the voltage drops around the closed circuit in a loop is equal to the resultant electromotive force applied in the given electrical circuit. That electromotive force may be battery or a generator. So voltage drops around any closed circuit. So how many elements are there in the given circuit? You have to see and write down all the voltage drops of each element and sum all the voltage drops of each element and add it. This summation must be equal to the applied electromotive force in the circuit. Whatever the electromotive force you applied, either battery or a generator, so that sum is equal to resultant electromotive force in the circuit. And another one, second law is the algebraic sum of currents flowing into any node or from any node. So flowing into the node or coming out of the node is a 0. So if you sum the currents entering into the node and leaving from the node, so if you can add these total sum, we will get 0. So the amount of power entered into the node will be same amount of current will be leave from the same node. So that algebraic sum is equal to 0. So therefore this summation of currents entering into the node and leaving from the node, total sum is equal to 0. So algebraic sum of voltage drops around any closed circuit. For example, here resistance, inductance, electromotive force, EMF. Here voltage drop across the closed circuit is a sum. Voltage drop across the resistance plus voltage drop across the inductance is equal to electromotive force, that is E, or otherwise V suffix R plus V suffix L plus V suffix E is equal to 0. So therefore that is a algebraic sum is equal to resultant electromotive force. Therefore now and second law, that is algebraic sum of currents flowing into or from any node is 0. For example, this is one node. This is one node. Now the currents entering into the node, leaving out from the node, for example, say this is I1 is the current entering into the node and I2 the current leaving the node, and this is I3 leaving the node and I4 entering the node, I5 entering into the node. As per the algebraic sum of currents flowing into or leaving from the node is 0. Therefore, here the currents entering into the node can be treated as positive. I1 entering into the node positive, and I4 entering into the node, I2 leaving the node considered as minus, I3 leaving out from the node minus I3, I4 is entering into the node, so plus I4, I5 entering into the node, therefore that can be treated as positive. Therefore this is a 0. I1 minus I2 minus I3, I4 plus I5 is equal to 0. So algebraic sum of currents entering into the node and leaving from the node. So entering into the node can be treated as positive and leaving the node can be treated as a negative. Therefore, this sum becomes a 0. This sum becomes a 0. This is the node. This is the second law of Kirchhoff's current law. The above law is a voltage law.